find the area of a region, two main functions, find the area between those. Here for this problem we're given y equal to x squared minus 1, and then y equal to negative x plus 2, x equal to 0, x equal to 1. So what we want to do is first to be able to graph So one, first graph the functions. Number two, determine the endpoints, or determine the points of intersection. Here you want to be able to determine what is A and what is B. So x equal to A and x equal to B, so that we can build the integral for the area, that it's some integral from A to B, some function f of x minus g of x dx. Also from the graph, be able to determine the upper function and the lower function. F of x and the lower function g of x. Hopefully from there you should be able to integrate and find the area. Well, let's see. So for this problem, we're going to graph. So we first graph x squared minus 1. So it's a parabola. It goes down 1 on the y-axis. And then we have the straight line, which is decreasing, negative x plus 2. And so here, if x is equal to 2, then we have y is 0. And if x is equal to 0, y is 2. So let's see if we're there. And here for x equal to 0, y equal to 2. And then when x is equal to 2, so y is 0, so something looking like that. Then it tells you that x is equal to 0, x equal to 1. So x equal to 0 is here, then x equal to 1. So this is the region that we need. And if that's the case, then we don't have to solve for the points of intersection, because this region that we're determining that is bounded here is fully enclosed. So the top function would be the straight line. So this would be our f of x, and then this parabola would be the g of x, the function down below. Obviously, we're going on the interval from 0 to 1 for x. So 0 less than or equal to x less than or equal to 1. So a is equal to 0 and b is equal to 1. So the area is the integral from 0 to 1. That top function is the negative x plus 2 minus the x squared minus 1 dx. So we integrate the integral from 0 to 1. Simplify that. This is negative x plus 2 plus 1 is plus 3, and then minus x squared. So we integrate here. So we have negative x squared over 2 plus 3x minus x cubed all over 3. Integrate this from 0 to 1. So we plug in x to equal to 1. So it gives us negative 1/2 plus 3 minus a third. And then we evaluate these terms at 0, and they're all 0 there. So we simplify this. So we have 6 as our least common denominator. So we have negative 3 plus 18 minus 2. And so this gives us 13 over 6. And I'm always cautious about my graphs when I don't find the actual points of intersection. This this polygon could come out like here. You know, I didn't put any numbers on my graph. Did that on purpose because I'm basically just sketching a graph to get an idea. But I am positive that this is correct. The graph may be a little bit shaky, and I saw that I could get away with it because they give us these boundary lines for x equal to a and x equal to b. It might not be the case in some of the other problems, and we'll see when we get there. And then I'll go into depth as well with these steps. Number 18. So we're given here y equal to negative x cubed plus 2, and then y equal to x minus 3, x equal to negative 1, x equal to 1. So if we would consider the graph for this, the parabola we're familiar with, well, the hyperbola, excuse me, x cubed, and then the plus 2. So I'm going to shift up 2. If it was positive x cubed plus 2, we would do a graph looking like that. But since it's negative, just reflection there with respect to the y-axis. And then for the graph y equal to x minus 3, if x equal to 3, then the y is equal to 0. So if x equal to 3, and then if x is equal to 0, y is equal to negative 3. So let's say we're somewhat here. And so this graph does this. And so this is y equal to x minus 3. And then this is y is equal to negative x cubed plus 2. And then it says x equal to negative 1 and then x equal to 1. So we need to extend this line on out. So x equal to negative 1 stays here, and then x equal to 1 is there. So we're talking about everything in this region. So over here, we have this vertical line, x equal to negative 1. Then we have a vertical line there, x equal to 1. You see the top function is going to be that hyperbola, then the bottom function is going to be the line, right? So we can get the height. And so x is bounded by this negative 1 and 1. So the area is equal to the integral from negative 1 to 1 of the top function. The top function is this curve, negative x cubed plus 2. And then that's minus the bottom function, which is the line there. So minus parentheses x minus 3 dx. We simplify this. This is negative x cubed minus x plus 5 dx. We integrate there, so we have negative x to the 4th over 4 minus x squared over 2 plus 5x. Evaluate that from negative 1 to 1. So we plug in x to equal to 1, so we get negative 1/4 minus 1/2 plus 5. And then minus, evaluate these terms at x equal to negative 1. So it's a minus, this minus, so that's positive 1/4. Minus this minus is positive 1/2. And then this is minus 5 times negative 1, so that's positive 5. So let's see what cancels out. So the 1/4 cancel, the 1/2 cancel, so the area is 10. Next one. So here, you know, the previous two problems, they told us something over here, x equal to something, x equal to something else. Well, on this guy, they don't. So in order to graph, we need to do some preliminaries. Now, this f of x, if you factor out of x, this is x plus 2. If I set that function equal to 0, this implies that x equal to 0 and x equal to negative 2 are our x-intercepts. So if that be the case, we can go ahead and graph that function as parabola shifting upward. With x-intercepts at 0 and negative 2. This guy is doing something like that. And then, so that was for f. So what about g? Well, g is a function that is progressing upward, is increasing. So it has a y-intercept at 2. Then it's going to shift like this. I guess I need to erase that f and put it on the other side. And that wouldn't mess up all of that. That's pretty cool right there. So the line is G and F is there. So the area that we want to calculate is what I'm going to shade in terms of this redness. Now I see 2 points of intersection. I see this point here and this point there. To calculate that, we set both of the functions equal. So we have x squared plus 2x is set to equal to x plus 2. We are solving for the points of intersection, right? So here, to solve for the points of intersection, we set the equations equal. And solve. So here, for this equation, these two equations set to equal, we have x squared plus x minus 2 equal to 0, dual factoring. So we have x minus 1, x plus 2 equal to 0. Well, that implies that x equal to 1 and x is equal to negative 2. So this is x equal to 1, and over here x equal to negative 2. So we have our lower and upper limits for the width. So negative 2 less than or equal to x less than or equal to 1. We have the top function, which is that line, and then the bottom function is the curve, so we can get the area now. The area is the integral, negative 2 to 1. The top function is the line is x plus 2 minus the lower function, which is the curve, x squared plus 2x. We simplify and integrate. So I'm going to write that negative x squared first, since it's the biggest term. This is x minus 2x, so this is minus x, and then just plus 2 dx. We integrate. We do not hesitate. Yes, we integrate. So minus x squared over 2 plus 2x, evaluate that from negative 2 to 1. And so we plug in x equal to 1, gives us negative 1/3 minus 1/2 plus 2. Now we evaluate the x's at the negative 2. So it's a minus this minus, right, which is positive. Then it's negative 2 to the third, that's negative 8 over 3. So then it's minus this minus, that's positive. And then this is negative 2 to be squared, so that's just positive 4 over 2. Then it's minus 2 times negative 2, so that's plus 4. Now we simplify this. Mercy. All right, so this is negative 9 over 3, so that's just negative 3. Then we have minus a half. Just write that last. Let's get the numbers first. So this is 2 plus 2 is 4 plus 4 is 8. Then minus a half. So this is 5 minus a half. We get 9 over 2. Okay. Are you happy now? Let's look at another one. Two functions given again. We want to be able to find the area between the two curves, however they're situated on the graph. So we need to find for this first function its intercepts to be able to see where it actually crosses the x-axis. So for this one, y equal to negative x squared plus 3x plus 1. This implies that x, using the quadratic formula, is negative 3 plus or minus the square root of 9 minus 4 times negative 1 all over 2 times a, and a is negative 1. So here we get negative 3 plus or minus the square root of 9 plus 4. So that's the square root of 13 all over negative 2. So x of 1 is something, and on a calculator, so this is negative 3 plus the square root of 13 all over negative 2. And that one we get negative 0.303. And then x sub 2, so negative 3 minus the square root of 13 all over negative 2. We get 3.303. So it was approximate, right? So if that be the case, this guy's doing more downstairs than upstairs. Let's do it like that. So this parabola it concaves upward, so it touches the x-axis. Oh, red would be better. Very close to the origin, and then over here, and we're just gonna do something like that. And then for the line y equal to negative x plus 1, I reckon it'll be good to know where they cross. So we set them equal. Set the functions equal. So we do that. We have negative x squared plus 3x plus 1 is equal to negative x plus 1. And so this gives us here the implication negative x squared plus 4x. And we can factor out an x. We have parentheses 4 minus x. We set that equal to 0. That implies x equal to 0 and x equal to 4. Okay, so let's see. This y equal to negative x plus 1 lets us know that this graph is going down. Okay, and so let's see where we could find that. If x is 0 here, it says that going down that way, excuse me, backwards. X is 0, y is 1, and it's going to be at that point there. And then my neck, I tell you, sit in this chair like this, it's not good. And then since x is 4, so this was 3 point something, so 4 is right over here, so they're going to cross down there. And that's 0 on the origin. We get that. We're looking for what's in between. Isn't that a daisy? Well, drawing's not so good. My drawing is not so good, but it's okay. It's okay. So we get the top function. That's the upside down parabola. And then the function down below is that line. And then we know where we're integrating from. We're going from 0 to 4, right? So the area is equal to the integral from 0 to 4. The top function is that parabola, negative x squared plus 3x plus 1. Then minus the function below is the line minus x plus 1. Simplify that. This is negative x squared plus 4x dx. The 1 minus 1 cancels out. So we integrate here. So we have negative x cubed over 3 plus 4x squared divided by 2, which is just 2x squared. Evaluate that from 0 to 4. So that gives us negative 64 over 3 plus 16 plus 2 is 32. And on our calculator, we have negative 64 over 3 plus 32. That gives us 32 all over 3. Okay, good. Well, just one more. Y equal to x, y equal to 2 minus x, and then y equal to 0. I want to show you 2 ways of solving this. One with respect to x and then the other with respect to y. Then you can pick which one is the easiest. The one that's going to be easier is going to be the one with solving this with respect to y. But sometimes it might be kind of difficult to wrap your mind around that. So we can just graph this directly. It's just some straight lines here. So y equal to x, and then y equal to 2 minus x. So when x is 2, y is 0. Excuse me, let's go back. Okay, I got the first one wrong. Actually, I'm drawing the second one for the first one. But let me just start over. Get it right, get it right. sorry about that, y equal to x this way. My right brain somewhat gets in the way sometimes, but it's good when you can check yourself. And so here, 2 minus x is going decreasing, going downward. And when x is equal to 0, y is 2, somewhere up there. And then when x is 2, y is 0. I'm just going to just draw the dang on thing, right? Okay, good. Alrighty. Let's use this color. Hadn't used that yet. Y equal to 0, this line right here, is the x-axis. Okay. Now if we use x, we have to cut this up to find this. Find that midpoint there. All right. Let's see what that is, what this point is. We know that this point here is 0. We know this point over here is 2, right? This is this line y equal to 2 minus x. So when x is equal to 2, y is equal to 0. What about here? Well, my graph is awful, but we're going to get 1 here. Let's see. Set these two equations equal. And so we have 2 minus x is equal to x. 2 is equal to 2x. X is equal to 1. Okay. So the function that's up top from 0 to 1 is y equal to x, and the function that's down below is y equal to 0. Right? And so we have two areas, the first area, then the second area. Then you move from 1 to 2. The area that's above is 2 minus x, and the area that's below, the function that's below is y equal to 0. Right? So for area 1, we have the upper function, which is x, and then minus the one on the bottom, and then for area 2, we have the function that's up above, which is the 2 minus x minus the function that's below, which is the y equal to 0. So we're going to put them together. So then the area is first, this is the region from 0 to 1, and this is the region from 1 to 2. So we integrate from 0 to 1. This is just x dx plus the second area, the integral from 1 to 2. This is 2 minus x dx. So integrating here, we have x squared over 2. Evaluate that from 0 to 1. Then plus 2x minus x squared over 2. Evaluate that from 1 to 2. So we get, for the first one, we just get 1/2. Then for the second one, we have plus, evaluate these two at 2. So that's 4 minus 4 divided by 2 is 2. And then minus, evaluate these terms here at 1. This is minus 2 plus 1/2. So this is 4 minus 4 that goes out. We have 1/2 plus 1/2. So the area is equal to 1. Now what if you wanted to change it around to, see, this was two integrals. Um, what if you want to just calculate this with respect to just one integral? You can do that with respect to y. If you look at this graph with respect to y, so just say this is one way. If you look at the graph with respect to y, that is, with respect to x, you look for two vertical lines. With respect to y, you look for two horizontal lines. So the two horizontal lines were here. If x is 1, y is 1. And then down here we get y equal to 0. And so for the region with respect to y, you don't consider the upper function and the lower function. Here you consider the function to the right, which is the highest value with respect to y, and then minus the function that is to the left. So the function that's to the right is this line y equal to 2 minus x, and the function that's below or to the left would be the line y equal to x. So with respect to y, we have 0 less than or equal to y less than or equal to 1. And then for the height, I guess I should be saying that correctly. For the height, we have the function that's furthest out. Here would be 2 minus x, and then minus the function that is within, or the lower, or the one to the left. So that's the line y equal to x. And it has to be with respect to y, so forgive me. Just here, since we have this reflexive equation, y equal to x, just replace the x's with y's. Good, remember that. So this is 2 minus y minus 1. So this is just 2 minus 2y. Let me do that down below where we have some room. So the area here go from 0 to 1 with respect to y. And then it's the function that's to the right. Again, that was 2 minus y. Then minus this y here. So we just got 2 minus 2y. With respect to dy, integrate here. This is 2y minus 2y squared divided by 2. That's just y to the second. Evaluate that from 0 to 1. We get 2 minus 1. We get 1. So either way you do it, you get the same thing. Now, I'm not saying do it this way or do it that way. Just do it either way. And hopefully you'll get it right. That is our hope. Thank you.